We're going to be starting our new trig unit today, and we are going to be focusing on how to solve different types of trig equations. Today we're going to be talking about how we can simplify and factor trig expressions before we get into actually how we go about solving trig equations. So a couple of things to remember as you are thinking about how you can simplify these trig expressions. So when you're simplifying, you want to try to write trig expressions with as few trig functions as possible. Try for only one. That's not always going to be possible, but that's what you're always trying for. Try to write it with as few terms as possible, and always try to get it down to terms with degree 1. As always, if you're simplifying, you're not always going to be able to simplify something down all the way down to just one little thing, but these are kind of the ideas that you want to stick with. So try to get it to as few trig functions as possible, as few terms as possible, and with terms in degree 1. Now there are a couple of tricks to go about trying to simplify these expressions. So some tricks. So one trick is to try to write everything in terms of sine and cosine. Now because you have all of those trig identities now, you know that everything can be related back to sine and cosine. If you have something in terms of tangent, right, you can use a quotient identity to write it in terms of sine and cosine. If you have cotangent, also a quotient identity. In terms of secant and cosecant, those are the reciprocals of sine and cosine, so you can write those that way. So that's one trick to get it to as few trig functions as possible. If you can get it down to just sine and cosine, you can see if there are things that will cancel each other out. Another trick is maybe sine and cosine aren't necessarily going to be the easiest to help you simplify something down, but you might be able to write everything in terms of just one function. So let's take a look at example 1. Simplify sine of x times cosine squared x minus sine x. So for this one, again, with these simplifications, they're sort of similar to proofs in that there are multiple ways of going about simplifying it, just like there are multiple ways of going about proving something is true. But the idea is we do want to get it down to the simplest form that we can. Now everything's already in terms of sine and cosine, so that might not necessarily help us, that trick. One thing you can look at is, well, we do have a sine of x in both the first and the second term. So if we factored that out, then we have one less function that's written out there. So factor out sine of x, that leaves us with cosine squared x minus 1. Now you see the 1 and you see the cosine squared, and that should start triggering your memory of identities, and the Pythagorean identities in particular. So we can substitute the 1 with sine squared plus cosine squared. Make sure you put it in parentheses so that the entire thing is subtracted. And then we can distribute that minus sign, and that leaves us with cosine squared and minus cosine squared canceling. So we're left with sine of x times negative sine squared x. And now we can multiply that together to get negative sine cubed x. Now that's as far as we will be able to go with this problem. So we were at least able to get it down from two functions down to one function, from two terms down to one term. We weren't able to get it down to degree 1, but there's no way for us to do that. Okay, example 2. Simplify sine theta plus cotangent theta cosine theta. Now here, this might be an example of somewhere where you want to see if you can get everything down to just in terms of sine and cosine. Because right now you already have sine and cosine in there, the only thing is the cotangent. So let's try to write cotangent in terms of sine and cosine. Now with a quotient identity, we can write cotangent as cosine over sine. Now this does look like it's going to get more complicated, but let's just see where this takes us. If I multiply those two together, I have cosine squared over sine theta. Now, if I'm trying to simplify this, right now I still have two terms. If I want it to be just one term, I'm going to have to add those two things together. That means I have a fraction as one of those things, So I need a common denominator in order to add those two terms together. So for that first one, if I multiply it by sine over sine, I end up with sine squared over sine. Now I can add those fractions together. So we have sine squared plus cosine squared, which is going to be able to be simplified down using a Pythagorean identity. All right, so sine squared plus cosine squared is 1. We have 1 over sine theta. And 1 over sine theta, actually we can even simplify that even further using a reciprocal identity, because 1 over sine is equal to cosecant theta. Now you'll notice, compared to last time when we were doing proofs and using identities there, with proofs you have to justify each step because you're trying to prove something is true. Here you're just simplifying, so there's no need to list out exactly what identity you're using. It should be pretty clear from your work, but because you're not proving something is true, you're simply simplifying an expression, you can just use the identities without having to write it all out. Now let's talk about factoring trig expressions. So when you're factoring, you're going to want to use forms that you already know. So for example, factoring by grouping, difference of squares, splitting the middle, all those different forms of factoring you're going to apply with trig expressions as well. You're going to treat the trig functions as variables. So instead of normally when you're factoring a quadratic, it would be, for example, x squared minus 3x plus 2. Now instead of x being the variable, you're going to have the entire trig function as the variable. So sine of x, for example, would be your x value. So let's take a look at some examples. For this one, factor secant squared minus 1. So you see two terms there, and you see secant is squared and 1 is a perfect square as well. So that should indicate to you that this is really just a difference of squares. So to factor that, pretend it's like x squared minus 1. Normally you would factor that x plus 1, x minus 1. So do the same thing here, but instead of x squared, you have secant squared. So this is going to be secant theta plus 1 and secant theta minus 1. And that's it. You're just factoring, you're not solving for anything just yet. Take a look at example 4. Factor 4 tangent squared plus tan minus 3. Now you'll notice here we've got 3 terms. So this looks like a good candidate for splitting the middle. Now if it helps you, you can feel free to, instead of writing tangent squared, write it in terms of just x squared, right? 4x squared plus x minus 3. That's really what we have here. If you prefer to do it that way, and you want to factor it that way, that's fine. Just make sure at the end, when you finally have it in factored form, just replace the x back with tangent theta. Okay, so if we split the middle here, so 4 times negative 3 is negative 12. We need two numbers that multiply to negative 12 but add to positive 1, so that would be positive 4 and negative 3. So this is going to be 4x squared plus 4x minus 3x minus 3. Factor by grouping. So the first two terms you can factor out a 4x. Last two terms you can factor out a negative 3. That leaves us with x plus 1 inside the parentheses both times. So that leaves us with 4x minus 3, x plus 1. Now you can do the same thing in the original form, or if you prefer to do it this way, you can just sub in for x and say that's equal to tangent theta. So if we did it in the original form, this would be 4 tan squared plus 4 tan theta minus 3 tan theta minus 3. In the first two terms, you would factor out the 4 tangent theta. That leaves you with tangent theta plus 1 in parentheses. Factor out the negative 3 from the last two terms, and that leaves you with tangent theta plus 1 in parentheses. Then that leaves us with 4 tangent theta minus 3, and then tangent theta plus 1. So that's it. That's just factoring it. Now, what if you had something like example 5? Notice here we have cosecant squared, and then we have cotangent. That's not a typo. So for this one, you want to, before you can actually factor anything, you want to be able to work with the same function. You don't want to be working with a cosecant squared and a cotangent. So as much as we can, we want to see if there's any way for us to get this down to something just in terms of cosecant or something just in terms of cotangent. Now there is a Pythagorean identity that we can use here, and that's cosecant squared is equal to 1 plus cotangent squared. So if we use that and simplify this down, that leaves us with everything just in terms of cotangent. So now we just have cotangent squared minus cotangent minus 2. Now again, you can relate this back to using x, so this is the same as x squared minus x minus 2. If you prefer to factor it that way, that's fine. But you're just looking for two factors that multiply to -2 and add to -1, so that would be -2 and +1. So that would be x minus 2x plus 1, or in the original form that would be cotangent theta minus 2, cotangent theta plus 1. Okay, our last example today. Rewrite the following so that the expression is not in fraction form. Now there are a number of ways to go about doing this, especially if you're just trying to get the expression down to something that's not a fraction. Now one thing you can do is you see that in the bottom we have 1 plus sine theta. Now one way to go about trying to get rid of that denominator is we can multiply by 1 minus sine theta over 1 minus sine theta. Now how does that help us? Well, if you look at the denominator, if we multiply by 1 minus sine theta, we'll be left with 1 minus sine squared theta. 1 minus sine squared theta can be simplified down to just one term, and when we have it down to one term, it'll be easier for us to be able to simplify it so that there's no fraction remaining. So let's go ahead and try that. So here we have 1 minus sine theta over 1 minus sine squared theta. Let's deal with that denominator, try to simplify it as much as we can. So we have sine squared plus cosine squared minus sine squared in the denominator. The sine squareds cancel. That leaves us with 1 minus sine theta over cosine squared. Okay, so we still have a denominator. So let's try to do this. Let's try to break this up into two fractions, and then we'll try to simplify each fraction down to something that's no longer a fraction. So breaking this up, it would be 1 over cosine squared minus sine over cosine squared. Now 1 over cosine, as you know by a reciprocal identity, is secant. And then the sine over cosine squared, we can break that up into sine over cosine times 1 over cosine. So we almost have it down. The sine over cosine we know can be simplified to tangent, and then 1 over cosine can be simplified to secant by a reciprocal identity. And that's it, right? We've gotten rid of the fraction. It's no longer in fraction form. We just have it as secant squared minus tan times secant theta.